Okay, guys, let's go through these. So let's stop the process here. I know the temptation is off the charts when you got blocks in front of you like this, right? Who knew a piece of like wood cubed would be so exciting? So let's go through these answers here. I want to make sure we're all good on these answers, so let's cease the building process here. Table, first of all. I haven't had a chance to check everyone's table, so let's go through this quickly. Somebody give me an example. We'll just knock out all 6 combinations so that you can verify that yours are correct. So get it started here, Mikey. Give me base dimensions.
Base dimensions, you can have 2 and 4.
So a 2 by 4 base area. Okay, what's your surface area there? Would not be 70. Yeah, this one would be 52. Yeah. And remember, this is inches squared, guys. All right, square inches. So anything area related, talking about that. Volume, Mikey. Right, and that would be cubic inches. Inches cubed. All right, give me a different combination here. Go ahead, Quinn. 1 by 6, area 6, height, surface area. 68 square inches. Volume, Quinn. Remember, guys, combinations can, just because you have different numbers in different order doesn't make it a different combination, right? So a 1 by 6 by 4 is the same thing as a 4 by 6 by 1. All it is just oriented differently on that one. Okay, give me another combination. Amelia? 8 by 3. I think we've all caught on to this point. Okay? Julian? The popular 1 by 24. Height? Surface area? Good. All right, we need 2 more. Go ahead, sir. What was it again? 2 by 12. So there's 24. Height? Surface area. What was it? 74? I think it's 74. Yes, it is 76, yeah. And 24 inches cubed. Last one. There? We already have the 2 by 4 by 3, which is where you're going to end up going anyway. Do 2 by 12. Do you see which one we need, Leah? A 2 by 2 by. Yep. Okay. So what's our surface area there? 56 and 24 inches cubed. Good. Okay. Now this next question caught some of us off guard a little bit when it says which requires the least amount of material. A lot of you looked at that and thought, well, I see over here that the volume is the same on all of them, so wouldn't it be the same? The answer to that is no. All right, because we're not looking at the volume. Why are we looking at the other measurement here, the surface area? Why would that represent our material? Quinn. Yeah, so the box is the material, right? Like that it's going to be required to make that. Whatever goes inside, that doesn't really matter. The volume doesn't matter. We're talking about the amount of surface area required to make this, and oftentimes it could be, it could be cardboard, it could be plastic, it could be whatever, okay? So in this case, which box do we want? Quinn? The 3 by 2 by 4? Yeah. If you look at the surface area, and that 52 square inches is the least amount. So then, consequently, which one would be our least desirable, maybe? Finn? Yeah. Okay. So if you were an advisor to a toy company here, and you were to offer them advice on which one they should choose, which one would you go with here? Which one would you say, which arrangement, which configuration of blocks would you recommend to them? And of course, why? Ellie? Okay, so let's go with the 3 by 2 by 4. Why would you say that one? So least material, sort of a regular type shape, okay? What you're going to find is it's going to be more like this type of a shape, okay, versus the long, thin version of it. Now, let me expand on this. If it's the least amount of material, why does the company care about that? Like, what's the significance there? Sarah? Exactly. The less amount of material, the less money. Okay? So I would go with that. Now, Ellie, you said your other one would be the 2 by 2 by 6, you said? And that was, what, 56 square inches, I believe, right? So it's close, but here's the thing. Do you think that ATC, in some sort of weird money-making scheme, decided to make more than one package of these things? Do you think they're going to try to make a bunch of, do you think they're going to try to sell more than one of these things? Yeah, it's usually how business works, right? So what's going to happen is, yes, the difference between those surface areas is minimal. Now, I don't profess to know exactly how much a packaging, maybe cardboard, costs per square inch. You know, it might be like 1/10 of a cent or whatever per square inch, whatever. And you might think, well, that difference isn't very much, but what if they make 1 million of these boxes? That certainly would add up over the course of time. So I would stick with this one right here for that very reason. It's less money. But I like the other reason that Ellie brought up. It's not an odd shape. It's sort of a compact shape, which is good for stacking, packaging. You know, if you're going to put it into a truck or a plane or whatever to ship it, it fits in there pretty nicely. All right, now, the million-dollar question here. Why do you think the company makes 24 blocks rather than 26? And do we have a generation of kids that are running around not knowing that there's a Y and a Z out there? I mean, because everybody, it's a rite of passage, right? You have to have alphabet blocks when you're little. Why do you think they went 24 versus 26? Jack? If you go 26, let's think about the combinations of 26, guys. What will we have here? What was it, Jack? Yeah, you could go like 13 by 2 by 1, okay? Or, Finn? That's it. All right. Now, if you compare them, obviously the 26 by 1 by 1 is similar to the 1 by 24 by 1, which had the most surface area, so cost the most. And then the 2 by 13 by 1 is like the 2 by 12 by 1, which is the second most surface area. Okay? So that means 26 is probably not the best option for that. Okay? So, how do they get away with this? And do they not just know, or do they not know that there is an X and a Y, or they just randomly, every box omits 2 different letters? Think that's how it works? So like, oh man, my box didn't have the E in it. All right, you just pray that you didn't get one that left out a vowel, so you can at least spell some words here. Hayden, what do you think? Yeah, so okay, so how, like, give me more, like on a block, can I borrow something? So on a block, what are you saying on these? So each face, you're talking a different letter. Okay, so yeah, it's not like, okay, All right, can you hand me my A block? Yeah, here's your A block. A. Great. All right, where's the B block? Well, here's the B block. And then your C, and then D, etc. Well, that's going to be pretty tough. All right? Poor Quinn wouldn't be able to spell his name. All right? He's going Q, U, I. I'm good. There's the N. Good. I already used the N. I'm out. All right? Sarah couldn't spell her name. All right? She got S-A-R-H. All right? So, no, Hayden's right. You're going to mix them up. All right? You don't have one letter on every block. That would be the worst business decision ever. Okay? Because you couldn't spell much with that. So what they do, not only do they do that, is they'll mix in numbers in there as well. Like I know this from experience because I have some at home. All right, you got some of the faces, you got different letters, so that gives you the freedom to be able to spell, to be able to do all the different things that you need to do with them. Okay. For that very reason, the money reason behind it, the configuration, presents a better option for us when we have 24 versus 26. All right, let's do that. How close were we on the definition here? You do not have to completely revise your definition. Some of you might have said something about the amount of cubes that would fit inside of an object. I don't know how many of you use the word fill. Well, when you say cubic, then that you're implying volume. So that would be fine, as long as you know we're talking about inside, but measured in cubes. The amount of units in it, yeah, Miss Cubic. Right. A lot of different ways to describe it. Okay? But I knew you guys had some familiarity with volume. So then they ask you to do a 12 block experiment. All right? So now we're only doing alphabet blocks with 12. That would be a little bit challenging there. So just somebody give me your example here. I'm going to take one and go with it. If you didn't have the same one, oh well, not a big deal. We'll move through. Go ahead, Isaac. What do you have? So a 3 by 2, area of the base. Anybody have that 3 by 2 by 2 like Isaac did? Okay. Now without checking, that would be the least surface area. Does anybody know why or how I knew that that would present the least amount of surface area? If I had to use 12 blocks, I'm saying. Why? Isaac, go ahead. Not necessarily, okay? There's another way to look at it. Quinn? Well, I could go with a 6 by 2 on the base, or 6 by 3 on the base, and get a base area of 18. I'm sorry, I shouldn't say it like that. No, actually, not necessarily, although that does contribute to it. I don't want to completely just dismiss. Go ahead, Julian. All the numbers are what? They're prime. That's good. You can't be broken down into any more factors. So when they're prime, Julian, what does that tell you about the look of the object, the prism in itself? What's it going to be? Exactly. Yep. That's exactly what we're looking for. Very good. Yep. The more compact of a shape you can create, the more cube-like. I mean, ideally we could go cubes, but you couldn't do a perfect cube out of 12 blocks. But the most cube-like is going to present the least amount of surface area. Because if you think about it, when you put all these faces together, they get covered up and they're not on the surface anymore. But when you elongate them with the 12 by 1 by 1, pretty much every face is exposed, and it counts for surface area. All right? So I asked you, how do you find the volume of these? And what'd we say? Go ahead, Brady.
I got for a regular prism base and height, but base times height rather. But for triangular prisms, base times height divided by 2.
Now let's clarify the base. When you say base, do you mean like a single linear dimension when you say base? Or is there more to that? Like for instance, okay, so like when I go back to this 3 by 2 by 2,
From a 90, coming from a 90-degree angle would be the height.
so you're talking about, are you multiplying like your base times your height? So base is a number, height is a number. So like on this particular one, like here, what would you multiply?
Base, most likely be 150 by 25 because the 90-degree angle.
So what would you say is the base? If okay, so that answers my question, because when you said base, it's not just a single linear dimension. What you're telling me is the area of the base. Is that what, did anybody say something like that? If you find the area of the base and multiply it by the height, you'll get your area, or you'll get your volume? Not as popular. How many of you just said you do length times width times height? Okay. Now, I agree to some extent, but we're going to run into a problem here, because when you look at this example that's presented next, this volume is 1,250 cubic centimeters. So if I follow your guidelines and say, oh, all you do is you take your length times your width times your height. We're doing 10 times 10 times 25. You're going to get 2,500 cubic centimeters. Now, I know you guys have a remedy for this. What would you say to do? And Brady was saying it as well. Jack, what would you say? You divide it by 2. Now, why am I dividing it by 2, Jack? Yeah, because it's a what? It's a triangular prism, right? And you think about the formula to find the area of a triangle, you take 1/2 times your base times your height, correct? So when you're finding the volume of a triangular prism, you're taking half of length times width times height. But here's the issue, guys. Then what happens when I say, okay, guys, the next thing I want you to do is find the volume of this hexagonal prism? What are you going to do? You're going to take length times width times height? That won't work, because you're saying, okay, if I call this like the height, where's the length? Where's the width? That's not going to work. So I'm going to go back to what Brady had said earlier, because when I go down here to my volume of a prism formula, and I know some of you had this written when I went around, the volume of a prism, I'm going to write capital B times H. Now, capital B implies that there's a calculation that goes into getting that variable. Because capital B represents what? B is the what? Mikey? What about the base?
The area.
Good. It's the area of the base. Now, I don't want to discourage you guys when you're given a rectangular prism from just doing length times width times height. Do it. That's fine. Because you're following this formula. Because when you do length times width, you've got the area of the base. Then you're just taking that times the height. Just like when you do length times width times height divided by 2 to get a triangular prism. That's fine. Because to get the area of a base, you would take length times width divided by 2 times the height. This really only is going to trip us up potentially when it doesn't fit into either of those two categories. Like if it were a trapezoidal prism or a hexagonal prism, like I showed you. But otherwise, I think we would be able to navigate this. All right, so down on the bottom example here, what'd you get for your volume? What is it? JC, what do you have? 96 cubic centimeters. Good. What'd you do to get that, JC? Uh-huh. Good. All right, length times width times height, cut it in half, triangular prism. All right? So now in general, that's how you're going to handle any type of prism. Area of the base. Now the area of the base, guys, is just the amount of blocks that'll fit on a layer. Isn't that what we just did? I mean, if you made this table, if you look here at these two columns, I'll highlight them for you. Base area, height. If I multiply these two columns in every single one of them, I get the volume of 24. That's not a coincidence. I could have done that with any prism, okay? As long as you're getting the area of the base and multiply it by the height. All right, now we're just going to close out. We're going to do a couple practice problems here.